Let's now discuss how to represent the data graphically. Why is graphical representation of data important in today's world? Now, look at the table and try to relate it with a graph. Since the data is very small, tabulation is easier. But when the data is complex, it's easier to represent it in graphical form. Graphs are a method to visually illustrate relationships in the data. The purpose of graphs is to present data that are too numerous or complicated to be described in tabular form. Now, look at the graph in here. Percentage of cigarette smokers from 2012 to 2016. Observe there are gaps between the bars. These kind of graphs are called bar graphs. A bar graph can be defined as a chart or graphical representation of data, quantities or numbers using bars. Bar graphs are used to compare and contrast numbers, frequencies or other measures of distinct categories of data. Here, from the graph, we notice that the maximum number of cigarette smokers were in the year 2014 and the minimum number of smokers were in the year 2012 and 2016. Now, have a look at this bar graph, which shows the number of transport means chosen for a day by the people. Observe, there are no gaps between the bars. These kind of graphs are called histograms. A histogram is a graph which shows the frequency distribution which have continuous class intervals. Now, have a look at this graph which even shows a line graph above each midpoint of the bar graph. These kind of graphs are called frequency polygons. A frequency polygon is a graph constructed by using lines to join the midpoints of each of the class interval. The heights of the points represents the frequencies. Have a look at this graph and let's answer some questions. These are the number of absentees in class 9 in an academic year. How many students were absent in the month of April? As you look at the graph, check for the month April in x-axis and look for the corresponding number of absentees in the y-axis. And you have 6 absentees in April. In which month were the maximum number of absentees? In the graph, you see that the maximum number of absentees were in the month of October. As you see, the rectangular bar is at its maximum in that month. And in which month were the minimum number of absentees? The minimum number of absentees were in the month of January, as you see that the rectangular bar is at its minimum in that month. Now, let's consider another example. When the data is already given in the tabular form, how do you interpret a bar graph from the same? Here, we see that the expenditures of a family are in thousands, which means 1 unit represents 1000 rupees. For example, 4 units gives you rupees 4000. Basically, you can choose family expenditures and rupees on any scale. But for more clarity, I choose family expenditure on x-axis, which is horizontal, and rupees on y-axis, which is vertical. From the tabular form, we see grocery is of 9 units and we draw a bar accordingly leaving gaps. Similarly, leaving gaps between the bars plotted accordingly. It's always easier to plot on graph sheets than on the plain ones. Now, let's consider another example of students' weight in a class. We have it in tabular form. How do we represent the same in histogram form? The only difference of histogram from bar graph is that they are used for continuous class intervals but represent same as bar graph. Here, have a look in the weights column. The numbers are given in the form of range, that is 35.5 to 40.5, and the next class interval starts from 40.5 to 45.5, therefore making it as a continuous table. Here, I've chosen number on the y scale and weights on the x scale, and have plotted the bars continuously unlike bar graphs. Since my x-axis starts from 35.5, I've drawn a small breakage line to represent that it doesn't start immediately like 1 after 0. The numerical values on the upper side of the rectangle bars are the corresponding number of students with respective weights. Therefore, in the graph, we mark that there are 2 students who have scored between 35.5 and 40.5, 8 students who have scored between 40.5 and 45.5, and so on. Width of the bar plays a significant role in the construction of histograms. Rectangles are proportional to the corresponding frequencies in the previous example, but look at another example here, where the rectangles are not of the same frequencies. Here, 7 students scored marks below 20 and 8 students scored 70 above. Don't you think this graph is giving you a misleading picture? Yes. Earlier, this problem was not an issue. All the rectangles were of equal width. In order to gain proportional frequencies, we need to make certain modifications in the length of the rectangle. For that, we need to consider two requirements, which is select minimum class size interval. In this case, minimum class size is 10. Modify the length of the rectangle to make it proportional to the class size 10. From the graph, we see that the first width of the class is 20 and the corresponding frequency or length of the rectangle is 7. Therefore, the length of the rectangle is given by dividing the frequency by the width of the class size and multiplying the result with the minimum class size. Here, in the tabular column, first and second column gives you marks and number of students. Apart from those two columns, there is a third column in here that represents the width of the class, which is basically the difference between the range of the corresponding classes. For example, 20 minus 0 gives you 20, and so on. Therefore, the length of the rectangle is calculated by dividing frequency by width of the class size and multiplying the corresponding class size with the minimum class size of the table, which is 10 in this case. The resulting graph looks like this by plotting the new frequency distribution table. Therefore, here we have obtained proportional frequencies. Now, let's consider another example to represent frequency polygon. This is basically a histogram by joining the midpoints of the adjacent rectangles on the upper side. Look at the histogram here. Can we represent this histogram in frequency polygon? Yes, the midpoints of the rectangles are joined together to form a frequency polygon. Even without a histogram, a frequency polygon can be constructed by just knowing the midpoints of the class intervals. Here, we assume that there is a class interval of frequency 0 before 35.5 and 1 after 60.5 for completion of the line segments. Addition of two class intervals with 0 frequencies make the area of the frequency polygon the same as the area of the histogram. The corresponding midpoints are named as A, B, C, D, E, F, and G. Consider the marks scored by 51 students out of 100 in a class. Let's represent the same in histogram and frequency polygon. Please note that both histogram and frequency polygon have continuous class intervals. Midpoint of the class interval are called the class marks. To find the class mark of the class interval, we find the sum of the upper limit and lower limit of a class and divide it by the 2. Therefore, graphical representations of data can be classified into bar graphs, histogram, and frequency polygons.